So we are looking at the tangents worksheet, and we are starting with number 4. If the measure of angle AOX is 48 degrees, then the measure of angle AXB is what we are looking to find. You have 3 tangent theorems. One of the theorems says when a radius meets the tangent line, you get a right angle. And I made my class chant it over and over. So when a radius meets a tangent line, you get a right angle. It's probably not proper English. They form a right angle, whatever you want to say. So I can use triangle sum theorem, and I can do 90 plus 48 minus 180, and we get that this angle is 42. And then there's another theorem that said, if there's a segment that goes through this exterior point and it goes through the center of the circle, then it bisects that angle. So arc, arc. That angle has been cut in half. Angle BXA has been cut in half because it's one of your 3 theorems. It's only 3 tangent theorems. Know them. So since that's been cut in half, I know that this is 42 for a total of 84. Number 5 is almost the same exact thing. We're just working the other way. We know AXB is 38. We know that that angle, BXA, has been bisected because of our theorem, because the segment goes through the center and through that exterior point where the tangents are meeting. So we're doing 38 divided by 2, and we get 19 degrees for each angle there. 38 bisected, cut in half. When a radius meets a tangent line, you get a right angle. You could do it to both of these if you wanted to. And so triangle sum theorem says that this angle is 71. I'm just using triangle AOX. So that angle is 71. We know these are congruent triangles. We could prove them guilty of being congruent. That one's 71. So AOB is a nice, really obtuse angle of 142. 7. PA has a length of 15, and AR has a length of 8. Find PS. We did one like this in class during our examples. So we are using one theorem and one theorem only. When a radius meets a tangent line, you get a right angle. AR is a radius, and AP, PA, is our tangent line. So when the radius intersects a tangent line, that is a 90-degree angle. We have a right triangle on our hands. When we have right triangles, we know we can use good old Pythagorean theorem. 8 squared plus 15 squared, 289. We love it because that is a perfect square. The square root of 289 is 17. So we know that RP, the hypotenuse, is 17. But we need to find PS. And like I said, we did this in class. We know RS is another radius. So it's 8. So if RP is 17, we do simple subtraction, 17 minus 8, and we're left with 9 for PS. Okay, let's look at this circumscribed quadrilateral. Circumscribed just kind of means it's on the outside. We'll look at that a little bit more next unit. We know that AD is 6. I called the theorem that we're going to use here, oh, that's ugly. I called it in class the ice cream cone theorem or the snow cone theorem because it kind of looks like one. If 2 tangents from an exterior point, so let's say A, if those tangent segments are both tangent to the same circle, then they are the same length. So these tangent segments are the same length because they're going through this common exterior point. So the cone part of the ice cream cone, those 2 segments are congruent. So I'm going to take this 3. I'm going to find the cone. Where's the cone? Oh, there it is. And I know that this one's 3. And I take the 4, and I know that that one's 4 because I'm finding the cone. And then 2 and 2. 6 take away 3. It's a coincidence that that's a midpoint, not always a midpoint. 3, ice cream cone theorem, 3. We are looking at number 18. We know that we have some tangent lines. We want to find SA. We're going to pull a few theorems out of our bag of tricks. Remember, there's only 3 theorems. One of the theorems is the ice cream cone theorem, what I like to call it. If 2 tangent segments are coming from the same exterior point, then they are congruent. So if AC is 12, then AB is 12. Second theorem, when a radius meets tangent line, you get a right angle. And now the rest is just Pythagorean theorem. We have a right triangle. I think 6 squared plus 12 squared is 180. And Pythagorean theorem, the last step is always to take the square root, so we need the square root of 180. Let's see, I don't know, 18 and 10 we could do. 5 and 2. 9 and 2. 3 and 3. Okay, so a 3 escapes, you're gone. A 2 escapes, and a 5 is left over. So it looks like 6 root 5.